Moving is challenging. We wanted to understand what people find difficult or frustrating, and having spoken to them, we realized that finding a new neighborhood in a new city where you feel truly at home is not easy. Part of this, we realized, is because people value different things. Take Eric. He is studying to be a nurse. And this is Jessica. She's from the UK and she works in oil and gas. And this is Martin and Anna and their 2 kids, Ida and Ivar. But what do all of these people have in common? They're all moving to Stavanger for the first time. And they all have different priorities, whether they're buying a new home for their family or renting an apartment for the school year. There are lots of factors that you need to take into account when choosing where to live, and the navigation of these factors can be difficult on their own. Now, throw in an unfamiliar new city and the process gets even more complicated. Take Martin and Anna, for example. Martin has just signed a contract for a new job in Stavanger. He starts in a month. This means that he and his wife and their 2 kids will have to find a new home in Stavanger. Not only do they have to think about the house itself, but they also have to consider the proximity to a kindergarten for 1-year-old Ida and a good primary school for 8-year-old Ivar. They want to live in a big house in a safe, family-friendly neighborhood with lots of room for their children to play. But like most people, they have a budget to adhere to. And what about what their family will need in 5 or 10 years? Hence, we asked ourselves, how can we make it easier for Martin and Anna and other newcomers to a city to find the most suitable neighborhood to live in based on their current and future needs? Why not try using data analytics and the Sassveia platform to address this problem? So we decided to partner up with Stavanger kommune, who have a lot of open source data that could be useful to our analysis. So how did we go about it? Our first step was to collect our data. We've used multiple sources, including Statistics Norway and open source data published by Stavanger kommune. The next step is Esri. From Esri, we collected more data about Stavanger's neighborhoods and other regions defined in JSON files, or polygons. These polygons overlap the map of Stavanger. These JSON files contain some basic information, and using these areas, we were able to extract information about these neighborhoods from Esri. We did this by going over to the analysis part of Esri, choosing data enrichment and enriching the layer. For our SAS Hackathon submission, we pulled all of the data available grouped in these polygons, creating a new layer. For example, if we select the city region Madla, we can now see that there are approximately 10,000 males and 10,000 females, corresponding to a total population in this region of about 21,000 people. We can also see some other statistics, such as the average household size in this region. We can format this dataset as a table, download it from Esri, and eventually upload it to our Sassveia environment. Our data is now ready to be imported to the Sassveia environment, where we've used the Manage Data, Prepare Data, and SAS Studio tools to prepare our data before beginning work on the visualizations. To clean our data and reduce its dimensionality, we've used the Principal Component Analysis task in SAS Studio. This reduces the number of variables down to a manageable amount of components. Here we have the output of our Principal Component Analysis that SAS has performed for us. We have some statistical information in this plot, which tells us some information about the 4 principal components that SAS has created using the original 20 variables. The first principal component seems to be observations of a high amount of spending on food and beverages, as well as on alcohol and tobacco, whilst the fourth seems to be scoring high on recreation, but also on household gardening and tobacco. In the Modeling Studio, we have built forecasting models for our dataset. What we have done here is forecasted the population living in the areas of Stavanger according to the variable year. This is a simple example of what we can forecast in SAS. After importing the data into Sassveia and performing our data preparations, it is time to do some analysis and explore the data that we have collected. For this process, we've used visual analytics and the cluster function to cluster regions of Stavanger together. Now, our data contains information on a lot of different regions in the city, as you can see on the map. Using a non-supervised machine learning method, our cluster analysis has worked out well, increasing the quality of our insights and thus making the results more useful for end users. We can, for example, look at region number 3. The main part of this region is located here in the central part of Stavanger. And if you highlight this cluster using the cluster function, you can see that most households don't have children and that the population here consists mostly of young adults and middle-aged adults. We can also see that there are a lot of people that spend a lot of their income on food, beverages, alcohol, and tobacco. This is a very densely populated area, and the people living here have a comparably low purchasing power. This seems to fit in well with the central part of any city. One of the key aims of our solution is to make it possible for people to input information about themselves so that we can provide them with intelligent recommendations on areas of Stavanger that best suit their lifestyle needs. Again, we can use cluster analysis to perform this task. In order to perform live analysis in a visual analytics report, we have to first create a job for the visual analytics report to run. What we have done is export our cluster model, which, as you can see, is just basic SAS code. So we've exported the code and moved it over to Job Execution Engine in the SAS-Viya platform. This is a cluster scoring job, and you can see that it contains a scoring code. When we submit parameters to this job and run it, it'll score the data live, matching it to the regions and resulting in a table that we can visualize in Visual Analytics. We can, for example, see the average household size and how many schools and preschools there are within the area. We can also see the area's population density and total population, together with a future forecast. Today, there are 15 schools and 18 preschools, but how is this area going to look in the future? Let's go over to the city planning part of the tool. Here, you can select the public service that you are interested in. You can, for example, choose playgrounds, preschools, and schools. If you zoom into the area, you can see where the preschools are located, and if available, other information such as the address or school type. In this case, we have a private school. This is the current data, but we also have the ability to look into the future. And as we do so, we can see the plans of how Stavanger is going to evolve in the future. Here, for example, we can see that some schools and preschools are removed, while others are established. This can assist in the recommendation of neighborhoods, particularly to families such as Martin and Anna's. With information and preferences provided by Martin and Anna, we can run our code and provide them with recommendations for neighborhoods, as well as information for each of them, such as the demographics, how people spend their incomes, the number of schools and hospitals, etc. And remember Eric and Jessica? Eric is a student planning to live by himself on a fairly low income. These are the neighborhoods that the solution would recommend for him. And on the other hand, Jessica is a British 29-year-old woman moving to Stavanger to work in the oil and gas industry. Her preferences would result in the following recommendations. And what does this mean for Martin and Anna? Where they would previously have to collect information from several sources, like Stavanger Kommune's web pages, Finn.no, Google Maps, to try to make sense of a new city and where they fit into it, they can now use Neighborhood Fit as a supporting tool to help find their ideal neighborhood. They could, for example, answer a few details about themselves and their family, and with the power of analytics and machine learning, get a tailored selection of neighborhoods that would be the best fit for not only their current needs, but also for their future needs. We could connect solutions to touchpoints for foreigners moving or looking to move to Norway in order to improve the ease of their move and help them make more informed decisions about their choice of neighborhood. This would increase the confidence in their decision-making, ease transitions to new cities, and improve the security of their investments. We could also collaborate with real estate agencies and other property-related companies to connect prospective home buyers or renters with properties within their recommended neighborhoods, saving them time and effort. Properties that are available to buy or sell within these neighborhoods could also be integrated as a factor in the analysis, making the solution helpful for real estate agents and landlords as well. Finally, given more time to work on the model, we can increase the accuracy of our forecasts and recommendations and provide greater value to users and other stakeholders. This is Neighborhood Fit, helping newcomers find their future neighborhoods.